Hello, welcome back. How do you scare a cleaner? Supplies. Okay. We're going to do trig equations part 2. This is where we start applying, I guess, more complex reasoning to your trig equations, which are already somewhat complex. So we're going to take a look at different types of equations. The first type of equation you'll see is if we've got different domains. Okay, so in the previous exercise or the previous video, we were only working between 0 and 360. That's what you're going to be the most used to. But sometimes we're going to change the domain. In this case here, you can see this goes from negative 180 to 180. Sometimes we'll go from 0 to 720. You can change the domains and that changes the question, but it does not change the process. Okay, it's just one little thing we have to amend. The idea is the same. So basically for this one here, I've just said sketch and amend solutions. I know that's not very helpful, but let me show you what I mean. So I'm saying solve for x in between 0 and 720, but the thing I'm solving for is sine x equals to a half. So if I was to sketch this out, not only do I want to go up to 360, let's say 360 is here, I want to go all the way to 720. And so I've still got my 180. And if you remember much about, I think it's 540. If you remember much about your sine graph, by 360, it should have one full rotation. Okay, same thing here, whoosh, whoosh. And you can kind of see that if that peaks out at 1, my half will be here, and I should have 1, 2, one solution there, one solution there. And I should also have 3, 4 there. So let's talk about this question. I'm looking for 4 solutions here because between 0 and 720, sine x equals to a half, 1, 2, 3, 4 times. So first things first, as usual, find your first quadrant answer. So in other words, x equals to sine inverse of a half. Now I keep forgetting if it's 60 or 30. So I'm going to need to draw a triangle. If you haven't memorized, good on you. I don't yet. It will be sine 30. Okay, so x will equal to 30 in your first quadrant. And remember, because we're talking about all stations to central, sine is positive in more than one quadrant. It's positive in the first quadrant, and it's positive in the second quadrant. We can see sine is positive here. Sine is pos. Okay, so we're looking for 2 quadrants. Your first quadrant we already found, it's 30. Your second quadrant we found is 180 take away 30, which is 150. And so we found our first 2 solutions, but what we need to do is we need to find the next 2. And so I'm going to label this potentially, the easiest way to talk about it is this is technically my 5th quadrant. And then I also have one more, which is in my 6th quadrant. Okay, the reason that that happens is if I draw a little diagram here, you'll see what I mean. I'll go the first time around, let's go in red. I start from 0, I go to 90, 180, 270, 360. That's my first rotation. And then what happens is if I go around again, I keep adding 90 to it. So this would be 450, 540, 630, and then 720. So you can kind of see how this is my 5th quadrant is technically, it goes 1, 2, let's do this. 1, 2, 3, 4. And then it continues on to 5, 6, 7, 8, kind of going in that kind of rotation. So that means I'm trying to find the 5th and the 6th quadrant. The easiest way to do this is it's just going to be my first quadrant, but one full rotation later. So it's going to be 30 plus 360. And so for my 6th quadrant, I can see it's in my 2nd quadrant. So it's going to be my 2nd quadrant answer. And then one full rotation later, which is going to be 360. So for this one here, you can see that those are your 3 solutions. That becomes 390. That becomes 510. And that is honestly 510. Yeah, 510. And so that'll be your 4 solutions. So therefore you can say that x will equal to 30, 150, 390, and 510. And you can see here, hopefully, that all of our solutions lie in between 0 and 720. And we've got all the positive half solutions in between there. Okay, bear with me. This is going to be a different one where we have a negative from negative 180 to positive 180. So what I mean by that is we're used to seeing cosine look like this. But what we need to understand is it also goes back this way as well. And so we know that 180 would be roughly there. So that means negative 180 would be roughly there. And so I'm looking for all the solutions just for this little section in here. Now, when does cos x equal to negative half? Let's do this as we normally would. Let's do x equals to cos inverse of a half. Again, do I care about the negative when I'm finding my first quadrant answer? No. So x will give me something like, man, every time. You'd think I'd be better at this by now. It'll be 60. Okay, so x will equal to 60 in this case. There's my first quadrant answer. But now I take a look at my all stations to central. And let's take a look at, you know what, I'm going to draw it bigger. If I take a look at my all stations to central, I can see that cosine here, cos x is negative. So cos is neg. And where is cosine negative? Well, it's negative in the second quadrant and it's equal in the third quadrant. Now, this is the change. I go from 0, 90 to 180, and that's as far as I go. And then I go from 0 to negative 90 to minus 180. So I'm kind of going this way and this way. And my full rotation is technically from the minus 180 to positive 180. And so what I need to figure out here is if I can find that angle there, I should be able to find that angle there as well, going back to my related angles. Okay. So in other words, all I need to do is find my second quadrant solution. So my second quadrant solution, because this is technically quadrant 1, let me write this large in a color that you won't miss. That's quadrant 1. That's quadrant 2. Now, instead of talking about this as quadrant 3, I want you to think about it as this C is negative quadrant 1. And this negative 180 is negative quadrant 2. Okay. So what I mean by that is if you look at the graph, I know it's not a perfect graph, but I'm going to break it down as this. That's quadrant 1 in here. That's quadrant 2 here. I know it's not equal. Don't judge me for it. And then a similar way is if I take a look at where it cuts here, this is going to be the negative first quadrant. And this is going to be the negative second quadrant because it's reflected. Okay, so in other words, if I can find my second quadrant, boom, my second quadrant is found by 180 minus theta. So that gives me 120 degrees. And then to find my third quadrant, which I'm calling my negative second, it's just going to be negative 120 degrees. And we just need to double check. Therefore, x equals to negative 120 degrees and 120 degrees. Does that make sense for our domain? Are all our answers between negative 180 and positive 180? Yes. So that's it. Those are our two solutions. Okay, keep track with me. Keep going. So trig equations with compound angles. This one here is probably a little bit more intense. I'm going to have tan 2x equals to 1 or cos x plus 30 equals 0. We're going to have to introduce this little thing called a substitution, just to make our life a little bit easier. And we also have to convert our domain depending on what's been added or what's been compounded with our angle, which was just usually x. Okay, so we're going to convert the domain, use a substitution, solve as usual, and then convert back from u to x for our final solution. Okay, I'm going to do one example here. I'm going to say, okay, solve for that equals to negative root 3 on 2. So first things first, let's convert our domain. So I'm going to say we've got 2x here, so I'm going to use the 2x in my domain. So how did I get from x to 2x? I multiplied by 2. So I'm going to multiply by 2 here, and I'm going to multiply by 2 here. So 0 times 2 is 0. 360 times 2 is 720. Okay, now at this point, I'm going to introduce my u substitution, and I'm going to let u be whatever the compound angle is. So I'm going to let u equals to 2x. So if I wanted to, I could write this. There's no need to, but instead of writing 2x, I'm going to write it as u. So now I'm going to solve this. I'm going to say sine u should equal to negative root 3 on 2. Now, can you see that this from here on is a normal substitution question? Or it's a normal trig equation question. I'm just going to solve it in terms of u. So I'm going to say u equals to sine inverse of root 3 on 2. And I'm pretty sure that becomes 60. Now note, I didn't care about the negative because I'm solving, as all the other ones, I'm solving for my first quadrant answer first. And so if I'm looking here, all stations to central, I see that sine is positive in the, here I've got sine is negative, right? So I know where is sine negative? It's negative in the third quadrant and it's negative in the fourth, okay? Sine is neg. Okay, that little guy gives it away. So let's find our third quadrant. How do you find your third quadrant answer? Well, this is going to be 180 plus 60. How do I find my fourth quadrant? Well, that's 360 minus 60. And then I'm going to go, that's between 0 and 360. But remember, we're going all the way now to 720. So that means I need to do one more round. So if that's 1, 2, 3, and 4th, the other quadrants I need to find are technically my 5, 6, my 7th quadrant and my 8th quadrant. So in other words, that's 240, that's 300. It's going to be fairly nice. It's going to be 240 plus 1 full rotation. And it's going to be 300 plus 1 full rotation. So that's going to give me 600. And it's also going to give me 660. And that there, hopefully I've done correct, should be your solutions. I'll say therefore x, oh, my bad. U should equal to 240, 360, oh, sorry, 300, 600, and 660. And then the last step here is, remember, u equals to 2x. And so I just want to find what x equals. How do I go from 2x to x? I divide everything by 2. So my solutions should now be 120, 150, 300, 330. Now just take a look here. Let's double check. All our solutions of x between 0 and 360? Yes. So it's kind of a little bit of back and forth, but that's how we would solve something like this. For the interest of time, I am going to skip one of these questions because it's the same deal. But here's one more. So if I've got trig equations with more than one trig function, essentially it could look like sine theta on root 3 plus cos theta equals to 0. Basically, your goal here is to reduce the equation to one trig function. If you've got sine and cosine, I need to rearrange until I just get something on its own. So for example, if I've got this, I'm solving sine theta on root 3 equals to cos theta, where we're solving between 0 and 360, a nice standard domain. What we're going to do here is we're going to try and rearrange it so that I've got something nice. Now, generally, when I see sine and cosine, I'm thinking that I can either make it into tan or cot. Okay, so to do that, I'll need to put them together. So here's what I'm going to do. I'm going to go do some algebra here, move the root 3 over, and then I'm going to divide both sides by cos theta. So this becomes sine theta on cos theta equals to root 3. And what is sine theta on cos theta? Bing, 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 tan theta. And so essentially now I'm just solving for tan theta equals to √3 between 0 and 360. I would solve this as usual. Okay, so I'm pretty sure drawing a triangle, solving for the first quadrant, and finding that all stations to central, tan is positive in the first and in the third. 1, 2, √3. I think tan theta would be 60 degrees. I'm not going to go through how I did that. You can solve that yourself. So first quadrant is nice and easy, is 60. Your third quadrant, which we found because tan is positive. Tan is pos. And so that gives you third quadrant is going to be 180 plus 60 equals 240. Your solutions to this are theta equals to 60 and 240. Okay. A little bit of a mouthful, a little bit of a full-on thing. If you need to, slow it down, watch it again, go through it a second time. Do the spare question. See how you go. Okay, see if you can solve it. This is the extra version of trig equations. Hope you got something out of it, and I'll catch you guys later. Bye-bye.